Let's understand the difference between various terms that are commonly used, especially data science, machine learning, artificial intelligence, deep learning, and statistical modeling. These are all terms that are actually related to each other and used in similar context. We will try to understand the difference between them, also understand how they are related to each other. First, let's see the difference between the word data science, the term data science, and machine learning. Now, we have a fairly clear understanding of what machine learning is all about and what it does. But if you are thinking about what is the definition of data science, this is not formally and clearly defined. So, depending on who you are asking this, the definition of data science can change slightly. But in general, what data science and machine learning is or means is within a data science project, the part of the data science project that actually does the prediction component, the component that is responsible for making whatever prediction you are trying to do. That part, the software part of the data science project is machine learning. The software part of data science is ML. For example, let's take an example project where the objective of the project could be something like you want to predict if a given customer is going to default on a loan or not. Now, let's assume we have various different fields in your data. Let's imagine this is your data set. This has various different columns. Let these be the columns. Let's also imagine that this column, this is the Y column. I'm going to call this column saying whether a given customer is going to default. One is default or not. Zero is not a default. So the values will be zeros, ones and zeros over here. All right. And you have various fields like say the age of the customer, savings of the customer, right? All these different customer related information is present. And every row in your data set, this consists of various different rows, a large number of rows perhaps. And every row in your data set corresponds to an individual customer. So this guy has defaulted. Likewise, the second guy over here has not defaulted. Let's imagine this to be the case. Now, in this project, the part where you are building the software takes this particular or one of these rows, this particular row as an input and gives you back the result. This part is the input and this part is the result. The software part that does this activity is the machine learning component. That is given an input, it maps it to a corresponding output. Now, if this is the machine learning component, what is the data science component? The data science component might involve the machine learning model here. This is the machine learning model. In addition to that, you might have some insights collected from your data. The insights, the model, and various different deliverables that you are giving out, the PPT or the dashboard, the model's results, the process of updating the output of a data science model into a database. All these activities are also important and is part of the project. So the entire package, which includes the models, insights, and the business deliverables, is the data science component or the data science aspect of this whole piece. Now, this is the distinction. If you go by this, machine learning is actually a subset of data science. The whole thing here is the data science project. Now, what is the difference between deep learning and machine learning? If you think about it, previously we saw that the software component or the component that makes the prediction is the machine learning component in a data science project. Now, the machine learning, when I say machine learning software or the component, it typically involves some sort of an algorithm that learns. And when we say machine learning, it is composed of a variety of such different algorithms, and they all together contribute to machine learning, right? Now, here, deep learning actually contributes to one specific or a special group of algorithms called neural network algorithms. There are so many different configurations of neural networks that you could design, and by changing the configuration or the architecture of the neural network, you can make it do different types of tasks. So what you see here on the left hand side, this is a very simple neural network. This is having a hidden layer. This particular layer over here is called the hidden layer. You have an input layer and you have an output layer. So this is where you give the input. A hidden layer of neurons is present and you get an output back. This is a basic simple terminology, right? Now, this is an example of a simple neural network. Now, if the hidden layers here in between, if it becomes more and more deep, if you have multiple hidden layers over here, then you have a deeper level of hidden layers. And that's where the word deep comes from. So deep learning is nothing but neural networks with a lot of hidden layers or deep layers. That's all there is to deep learning. So deep learning is essentially neural networks with lots of hidden layers, or in other words, at least more than one hidden layer. Now, I said deep learning can be used for various different purposes. With deep learning, you can use it to predict on tabular data or numeric data, just like what we saw for the loan default problem, right? When you have such a data, you might be able to use artificial neural network. ANN stands for artificial. This is the most common, most basic type of a neural network called artificial neural network. If you have image data as an input and you want to do some sort of a task over an image, you will typically go for a convolutional neural network. C for convolutional. Likewise, if you have a signal data or time series data or a sequence basically, you will go for long short-term memory network, long short-term memory network or recurrent neural network. These two are very popular types of neural networks for working with time series or sequence data. So now the difference between deep learning and machine learning is clear. Now, how are they all related to each other? Like I said, we have machine learning over here. Let me imagine this circle to be the circle for machine learning. I'll call this ML, right? Within machine learning, deep learning is a subset of machine learning. Now, artificial intelligence involves both machine learning and some activities that is outside of machine learning also. So, artificial intelligence is a superset of machine learning because it involves algorithms like reinforcement learning, graph based algorithms, and such. So, generally, the whole thing is artificial intelligence. Now, where does statistical modeling fit in here? Now, if you think about it, the objectives of statistical modeling, machine learning, and deep learning are highly interrelated to each other. The purpose is very similar, but statistical modeling involves the element of statistical significance. And whenever you see p values associated with the prediction model, then it typically means that it is a statistical model, which means typically algorithms like linear regression, logistic regression, such algorithms, whenever they are also reporting p-values along with it, it falls under the category of statistical modeling. So I put statistical modeling somewhere over here. It definitely comes within AI, but it has a lot of overlap with machine learning as well. Now, where does data science stand here? Data science involves a bit of all of these things, and depending on the person that you are asking, data science can either be seen as a bit of all of these things like this, like an ellipse running over here, something like this. This can be construed as data science, or the whole thing can be construed as data science as well. It depends on who you ask. So this should give you a fair idea of how all these terms are related.